Good,
Uh,
good evening, ma'am.
yeah, good evening, sir. So, shall we start?
Yes, please.
Yes,
Yes,
ma'am.
ma'am.
Yeah,
Yes, ma'am.
thank you. Thank you, everyone. So, yesterday we have discussed about the packages and functions. And after that, we have moved and we have seen few of the exercises that we can do. Apart from that, I have also told you something about the descriptive statistics, and we have seen a little bit about the graphical representation of the data also. Today, as per the schedule, I'm going to discuss probability distribution. So, give me a second. I'm just going to share my screen. Anyone will confirm me? Screen is visible?
Yes, ma'am.
Okay. Slides are visible?
Yes, ma'am.
Yeah. Thank you, ma'am. So, first, I am starting with the distribution term. Generally, we are knowing this thing that whenever we are concerned about the any statistical test, so we need to know about the distribution of the data, that how the data is scattered, how the data is distributed. So in statistics, whenever we are in understanding whenever we are interested to know that thing, we need to generally consider the probability distribution. The probability distribution is the distribution of the probability of the occurring of the events. Means if, for example, I am performing any experiments, so whatever is the event will be associated to that particular trial. So what is the probability of coming those particular events? So the distribution of that is known as probability distribution. Now, question comes whenever we are talking about probability distribution. So which type of distribution are having in statistics? So there are so many distributions available in statistics. But here from this particular FDP point of view, I'm going to discuss normal distribution, binomial distribution, and Poisson distribution. Maybe you have heard about the binomial Poisson and normal distribution before this particular FDP also. So maybe some of you are also knowing this thing that there are binomial distribution and there are discrete probability distribution and the continuous probability distribution. So which in these three distributions, which we can keep inside the continuous distribution and which we can keep inside the discrete distribution, that is the important thing to understand. So when I talk about binomial distribution and Poisson distribution, these two distributions are the part of the discrete probability distribution. When I'm talking about the normal distribution, so normal distribution we can keep inside or it is a part of the continuous distribution. Now question comes, what is discrete, what is continuous? So discrete and continuous both are the numeric. Numeric means they can accept the numbers. So both are numeric in nature. But the thing is, when I'm talking about discrete variable or discrete event, so it can accept the complete number. Say, for example, if I say, how many students are there in a school? So I think our question will, or the answer will be like maybe 20, 25, 30 or 60, something like that. But no one will tell me this thing that there are 20.5 students available in my school, because we are knowing this thing that the students or the human being cannot, we can say in the decimal points. It can be a complete number. So that way I can say that number of students, number of chairs in a class, number of vehicles running on the road. So these type of examples we can keep inside the discrete variable. Now when I'm talking about continuous variable or continuous event, so event or the variable associated to the event which can accept the value in a range, that type of variable is known as the continuous event variable. Say for example, if I say I'm interested in looking at this thing that the weight of the students in my class are normally distributed or not. So in that case, I need to know this thing that the nature of my variable weight is, it is a continuous type of variable, because Maybe we can find a person whose weight is suppose 45 kg or maybe 50 kg. Similarly, we can find a person whose weight is suppose 46.28 kg. So it is quite possible. So that way I can say weight is a variable which can accept a value in a range also. Means it can be a fractional number, it can be a number which can be in a decimal point also. So that way, continuous variable, generally whenever we are talking about continuous variable, so we need to be very much particular about its normal distribution. So if you have studied about the, maybe which we will discuss in the upcoming sessions, that we are going to discuss the t-test, ANOVA, etc. So whenever we are talking about the ANOVA, T or Z type of test, so there are generally we are dealing with the one variable or two variable. So in those two variable, three variable, or maybe in one variable, there should be a variable which should be continuous. May in case of two variable, there should be one variable which should be continuous, and other variable can be the categorical variable also. So that is the important thing. So for the purpose, that is why we have kept this particular session today, to understand the distribution of the data, because when we will talk about in upcoming session about the normal distribution, so we need to know this thing, that this particular type of variable is available in our data. So for this variable we need to check whether the variable is normally distributed or not. So that is why we are going to discuss distribution today. So again, I am just giving a recap what I just said, that whenever we are dealing with the discrete kind of variable or event, so in that case, we can apply binomial distribution or the Poisson distribution. But when we are talking about the continuous variable, in that case, we can apply the normal distribution. So I am starting with the first distribution for the day, that is the binomial distribution. So we can read on the slide that the binomial distribution model deals with finding the probability of success of an event which has only two possible outcomes in a series of experiments. For example, tossing a coin always gives a head or a tail. So the probability of finding exactly three heads in tossing a coin repeatedly for 10 times is estimated during the binomial distribution. So for example, I think with this slide, I think whatever I want to explain, I am explaining you that whenever we are talking about binomial distribution, it's first thing, it's a kind of discrete distribution. So in binomial distribution, whatever event we will consider, it will have only two outcomes, and those two outcomes will be the success or the failure. Say for example, if I said uh, a college has conducted a exam, so the outcome can be either the student will pass or either the student will fail. So there is only two outcomes. So in that case, I can say, in to study the probability of such kind of outcomes, in this particular scenario, we can use binomial distribution. One example you can see, it is listed here in the slide also. It is the when we are tossing a coin. So tossing a coin is an event. From tossing a coin, what outcome we are getting, it is quite known to us, that we will either get a head or either get a tail. So in which type of outcome we are interested in? Say for example, if I said I'm tossing a coin two times, and I'm asking what is the probability of getting a head. So getting a head would be a success. So that means if tail will come, that would be a failure for me. So this way, whenever we are talking about binomial distribution, we are generally having only two outcomes for any event. That would be a success or a event. Say for example, in a clinic, doctor has opened a clinic and he is expecting customers. So whether we can ask what is the probability of coming 10 patient on the particular clinic. Either the patient will come or the patient will not come. So that way, that would be known as the condition of the binomial distribution. So now, talking about binomial distribution in R. So what either I'm talking about Excel, means in Excel also we can find binomial distribution, but I'm talking about R. So in R also we can find the binomial distribution, as this FDP is totally depending upon the R. So you can see there are four different functions which we can use to get the binomial distribution. You can find here there are different functions available. The first one is the D binom, then P binom, then Q binom, and then R binom. D binom is density binomial probability. Q binom is P binom is the probability binomial distribution. Q binom is the quantile binom, and the R binom is the random number binomial distribution. So here you can see for these different functions, these are the parameters we need to pass here. When I'm talking about the D binom, here we can pass X, its size, and the probability. X would be the random variable. So if I said what is the probability that exactly 5 students will come today to attend the class, so in that case we will apply D binoms. That means whenever we are interested to find the probability of the exact event, in that case you need to use D binom. Similarly, when we are saying P binom, so if I say what is the probability what is the probability that less than 10 students will come to attend the class, or what is the probability that more than the 15 students will come to attend the class. So in that case, you can say whether I'm talking about less than or greater than or more than. In that case, this is the condition of P binom. Now, Q binom is opposite of the P binom. In the P binom, we are getting, in the D binom and P binom, we are getting answers in the form of probability. But in the Q binom, we are getting the probability, we need to pass the probability. You can see P is the first parameter here. So we need to firstly pass here the probability, and with the help of Q binom, we are able to get the value of our random variable. So it is opposite of these two. Last one is the R binom. So R binom is generally we are using to generate the generally we are using to generate the random numbers which are following the binomial distribution. So this way, these are the 4 different functions which we can use to get the values of the binomial distribution or probability of binomial distribution. So do I need to explain more? Is it clear? Can we proceed with R now? If you want, you can capture this particular slide so that these formulas will be with you.
Ma'am, can you explain D binom and Q binom again?
Okay. D binom means, as I said, what is the probability that 5 students will come to attend the class? Either student will come to attend the class or either they will not come. There are only 2 chances. Student will come to attend the class or student will not come to attend the class. So when I'm asking what is the probability that what is the probability that exactly 5 students will come to attend the class? So when I said exactly means when I want that this particular event will happen exactly. So in that case, you need to use D binom. So if 5 students will attend the class, you need to say 5 would be the value of the X. Similarly, when I'm talking about Q binom is the opposite of the D binom or the P binom, because here you need to pass the probability and then you will get the value of X. So this is the Q binom. Q binom is the quantile binom. Quantile means it's a variable. Generally in R, we can call a variable as quantile also. So the Q binom will give us the value of the variable when we are passing the probability. So is it clear? Vaishnavi ma'am, I think she was talking to me.
Yes, ma'am, it
Yes.
is clear. Thank you.
Yeah. So can we proceed to now R, and we'll see how we can apply these things. Is it
Yes,
okay?
ma'am.
Okay. So before proceeding to that, I'll show you the question for the day, which we are try to solve with the help of R. So you can read the question. I have shared the Excel sheet. I hope Excel sheet is visible. Is it visible to all?
Yes, ma'am.
Yeah. You can see the question is a coin is tossed 4 times. What is the probability of getting? First thing is no head. I'm increasing its size. I hope it's clearly visible to everyone. Yeah. So first thing we need to find what is the probability of getting no head. Second, what second we need to find probability of getting exactly 1 head. And third, we need to find probability of getting at least 2 heads. And fourth, we need to find probability of getting at most 2 heads. Question is clear? Anyone?
Yes, ma'am, clear.
Yeah, thank you, sir. I think I have taken few more questions that I'll show you afterwards. I'm writing down my question here. This is what is the question. So now, firstly, I'm writing here what is given in the question. So I think according to the formula is these two. Because we need to find probability, so it is quite clear. Either we will apply D binum or we will apply P binum. Is it clear to everyone? To get a probability, you need to apply the P binum or D binum. Is it clear?
Yes, ma'am.
Yeah. Now, if it is clear, so the question comes which function we will opt for. Either for D binum we will go or either we will go with the P binum. This is the next question. So, if we want to find the probability of the exact event or exact outcome, in that case, we will go for the D binum. So, for D binum, you can see what three things we need to have. We need to have the X value, we need to have the size value, and we need to have the probability value. Here, probability value is what? It is the probability of success. So, you can see X is 0 in the question, then size is the 4, and then probability of success is 0.5. Is it clear? Any doubt? Any doubt?
No, ma'am.
Okay. So I hope it is clear to everyone that how I have written here X size and probability of success value. Now, as we can see here that we are interested to get the probability of no head. No head means exact outcome probability we need to find. So it is quite clear we will go with the D binum. And then I can write here 0, comma 4, comma 0.5. Is it okay? Is it okay? May I press Control Enter? Any?
Yes,
Yes,
ma'am.
Yes.
0.5. How did the 0.5 come?
Okay. Okay. Yes, Vaishnavi ma'am, you can see here we are tossing a coin. Tossing a coin is what? It is a event, and outcome is what? Either head or tail, right?
Yes, ma'am.
So I think according to the formula of probability of success would be what? It would be 1 divided by 2 if I am interested to
Okay,
get a
okay.
head. So 1 by 2 is 0.5, right?
Okay, thank
Yeah.
you.
So you can see we are getting the answer as 0.0625. That is 6.25% chances is there that there would be no head will come when we will toss a coin 4 times. Is it clear to everyone?
Yes, ma'am.
Yes. Now next, exactly one head. So now can anyone tell me when I need to find the probability of getting exactly one head, which formula I'll use here?
That is P binum.
P binum. Anyone else?
Exactly one
D
D, ma'am.
binum. Yes, very good, sir. D
Exactly.
binum. Exact it is a case of exact, so we will go with the D binum. Yes, correct. Thank you, sir. Fine. Everything I have passed correctly, right? Can I press Control Enter? Is it fine?
Yes, ma'am.
Yes. So the answer is 25% chances are there that I will get exactly one head when I will toss a coin 4 times. Done?
Done, ma'am.
Okay, I think next one was the at least 2 heads. Next question was the at least 2 heads. Yes. at least two heads condition is. Can anyone tell me what we will find here?
P binomial.
P binomial. Very good. And at least two heads meaning is it would be this, right? At least two head is this. Whether I have written correctly or not, it is clear to everyone.
2 or less than 2, yes.
Greater than, X should be greater than or equal to. At least two means at least means I think in Hindi I can say kam se kam, minimum two.
The minimum amount of heads that we want
minimum,
is 2.
yes, minimum we want 2. Maximum it can be 4 also if we are tossing a coin 4 times. So that means we want to get the probability of P2 plus P3 plus P4. Is it correct? Yes, it is correct. Clear to everyone? So you can see for P binomial again we need to pass almost same parameters. But one more parameter will come here. I'll show you. Just a minute. I request to everyone, in front of P binomial function, keep a question mark sign and press Control Enter. And that way you would be able to see its description in the fourth window. And I request you please read the description. Yeah, this description after uses and the meaning of arguments is very important here. In that, I expect you to read the lower dot tail parameter. Maybe it is the size is very small on my screen. You can run at your end this particular line number 232 and please read at the right hand side window, lower right hand side window, the meaning of lower dot tail. It's a logical value. It is a fourth parameter in the P binomial, and by default it takes lower dot tail true. Means if I will not pass lower dot tail function here, so it will take it as a true. And if I'm passing lower dot tail as a parameter and I'm keeping it as a false, so what is the meaning of that? So by default it is true. It is taking a probability of less than or equal to. When I'm keeping it false, it will take the probability greater than. So this is you need to understand. You need to use here the fourth parameter also. Understood everyone?
Ma'am, can you repeat it once again?
Yeah, I think I'm rather than repeating, I'm writing here. So that would be much easier for you to understand, and that way you can make your notes also. Okay. So lower dot tail, it would be a
False.
logical parameter, right? Here you can pass either true or false, right? Now, when you are keeping lower dot tail equals true, and this is by default, right? So the meaning of this is it will give you the probability of less than equal to. Then we are keeping lower dot tail equals false. That means it will give probability of greater than. Is it clear now?
Yes, ma'am.
I think the sir who was asking, it is clear to you, sir?
Yes, ma'am.
Yeah. So now we will see how we can apply this thing here. So here we need to use a logic, whether we will go with the true option or the false option. So we need to find the probability of P2 plus P3 plus P4. At least means it can be maximum up to 4 also. So P2 plus P3 plus P4, this is what we need to find. So here I am writing 1, 4, 0.5, lower dot tail equals false. Is it clear? Any doubt? Anyone?
Ma'am, we have to pass one or two first parameter.
This is very good question, sir. This is the point to ask why I have kept here one. As I said, when I'm keeping lower dot tail as false, right? So when I'm keeping is false, it will take the condition of greater than, means
Right.
greater than to 1. So that way it will include 2, 3, and 4.
Hmm.
Is it clear?
Right.
So that is why I said we need to use our logic behind this. Now it's clear to everyone? Any doubt so far? Anyone? How many has joined the class today? I think we are almost the same as we were yesterday. Okay, that's good. So can anyone tell me, are you with me? Nobody is saying anything to
Yes,
me.
we have it
Yes,
here.
ma'am.
Yes, ma'am.
Everyone has performed it?
Yes, ma'am.
Okay, that's great. Now we are moving to the next condition. At most 2 heads. So here I am expecting, please guide me what I need to do. At most 2 heads. What I need to do?
Less than or equal to.
Okay.
So
Sorry.
by default, it's true. So,
In place of one, we'll put two, and lower tail will put true.
Okay. Like this. Is it fine, sir?
Yes, ma'am. I think.
I executed, ma'am. It gives same output.
It will give us same, sir, because thing is it's a distribution. So you can find 0, 1, 2, 3, 4. So it is equally divided. So that particular word 3 is the middle point. No, I think 2 is the middle point. 0, 1 will here, 3 will here, and then remaining 2 are here. 0, 1, 2, 3, and 4. So it would be a middle point. So both way it will give us the same probability. We will get the answer same, but the logic is different.
Right, ma'am.
Yeah. So it is fine. All are done with this. Everyone has understood this concept.
Yes, ma'am.
Can we proceed further?
Yes, ma'am.
Today
Yes,
we will do so many hunts on practicing. Firstly, I'll cover up all these things and then we will come back and we will do the exercises today. Okay, so now I'm moving again to the slides. Yes. Now I think I have explained. Okay, no, I need to do one more thing. I need to tell you one more thing here. Yes. Before moving to the Poisson distribution, I need to tell you one more thing. Suppose I am using R binum. So for R binum, what is we need to pass n, size, and probability. Means how many numbers from which sample we want to get and what is the probability of that. For example, I have written I want to generate 10 numbers from the sample of 100 whose probability is suppose 0.4. And when I'm pressing Control Enter, you can see it is giving me the answer. Means with the help of R binum, we can generate the random numbers who are following the normal distribution. Is it clear? It is clear.
Can we discuss with some example, ma'am?
This question?
Yes, ma'am. Like there are suppose 100 event. Okay, suppose we toss a coin 100 times. Now I want had it 10 times. And just suppose probability of had this 0.4 instead of 0.5. Is this the case like
No,
this?
no. It is not that case. Sir, R binom is only a function. Say, for example, I think, have you worked on Excel any previously, or do you have any idea about Excel, which can
Yes,
generate?
ma'am.
Yeah. So similarly, in when I think there is a function called random. So with the help of that particular function, we can generate the random numbers, right?
Okay, ma'am.
Yeah. So similarly, in R, it is a facility which will help us. Means I can give these instruction to R that I want to generate 10 numbers. Suppose the sample is 100. So from the 100 sample, I want to generate 10 numbers whose probability is 0.4. So that way, it is giving me this answer. When again I am running this, you will see it will give me some other answer. Because these are the random numbers. So every time the values get changed, you can see here. Second time when I have run the same line and I have printed it, so I am getting the value as this. So and as many number times you will run that particular line. So every time you will get the new random numbers. Similarly,
But point is that, ma'am, why we mentions the probability, and we can change this probability value.
yes, you can change accordingly. It will give you some new random numbers. Even you can
But if I
change the
give a
sample size
probability of
also.
1,
It will give you
then
some
there is
different
no
number.
change. No, not 0.1, just 1.
One. So one is
Yes.
the exact. I think you are knowing this thing. One is the complete probability, or one is whatever events we are taking. So the sum of all the outcomes of that particular event probability would be one. Say for example.
Yes, ma'am. That's what I'm saying. Now, suppose there are 100 number and 10 number, I have to select any random. And probability, I'm saying 1. So why it's taking one number all the 10 times? It should be different, no?
Sir, I think you're not understanding my point. You should understand my point. Just a minute. I'm going to some word file or somewhere. Yes. Suppose this is a file, which this is a question which I need to give you today. So suppose I said, as I said, I am tossing a coin, right? So in tossing a coin, suppose the probability of head, it is this. Similarly, the probability of tail is this. And so the sum of this would be what? It would be 1.
Okay.
Is this or not? So it is 0.5 plus 0.5. So it is quite clear it is 1. So whatever is the outcome of any event, the sum of that would always be 1. Probability cannot exceed to 1. But when I am instructing her, generate the 10 numbers from the sample size of 100 whose probability is on exactly 1 if you are giving. So it will generate the same number 10 times.
That's my point,
Understanding my
ma'am.
point?
In this case, probability of head plus probability of tail is 1.
So,
In
sir,
our example, just listen, the probability of getting 1, probability of getting 2, up to so on, probability of getting 100 is equal to 1. You get my point, ma'am?
no.
Because there are 100 numbers, we can pick any one number, and probability of any one number is 1 by 100. Now, if I give probability 1, then why it select 100? Why it's not 10 times 1 or 10 times 2 or 10 times 4? My point is this, ma'am.
Sir, I think maybe I am unable to explain you this thing, or you are not getting my point. I said this thing. Here we are passing that if you are writing, because probability can never be more than 1. So when I am exactly saying the probability should be 1, so that way it will generate all the same number. Always it will generate 100 for me.
Yes, that's my
Yes.
point. Why 100? Why
Because
not
I am
any one number between 1 to
say for
100?
just a minute. See this, sir. It will always, so it will give you this. It will divide this. So it always, if you are changing the sample size, even then it will give you the same. Suppose I have written here 222. Suppose it will give me same. So
So
whatever.
can we say, ma'am, key in case of probability 1, it doesn't consider range, it consider only one fixed number.
So repeat the line. I'm not getting your line.
When, ma'am, we mention probability 1, so in that case, it's not considering range.
Obviously, it is not considering range. It is quite clear. When suppose I have written here 0.2 like this. So that way it will generate 10 numbers out of this sample whose probability can be 0.2. So that way I can say 222 is divided. It is not divided from 222 sample. It is taking 10 numbers. Any 10 numbers it is taking whose probability can be 0.2.
And that's 222 numbers are from 1 to 222 or 1 to 100. What's
It's from 1 to 222.
right? So it may be the chances. It just consider only 2-digit number. Chances
Yes,
can be there are three digit.
when if you want to get 3-digit number, you need to take it to the you need to pass it here the 4-digit number
Okay.
like this. Now getting?
Still, it raises questions when we set any 10 numbers, probability is 0.2, and sample size is 1 to 222. Then why consider only 2 digits? Now, when I increase to 4 digit, it consider only 3 digits. But point should be the random numbers mean it can be 1 digit, it can be 2 digit, it can be 3 digit, it can be 4
Sir, thing
digits.
is, generally the number, as you say previously also, as I said, generally it is a probability is always a sum of from 0 to, so just a minute, again I'm coming here like this. So generally a probability is, suppose it is P0. Suppose there are 5 outcomes of any event. So I have written P1 plus P2 plus
Right. So on, we
P3.
can say whatever last number.
So P0 is always included there, and then it would become the sum of 1. So if I am giving 3-digit number, that is n minus 1. So as I said, it's just so it would be, that's why it is giving us a 3-digit number. When I am passing a 4-digit number, so from that sample it is giving us the 3-digit number. Okay, is it clear, sir?
Right. Okay, ma'am. I will.
Okay, maybe might be
Sir.
possible I am unable to explain you. I'll if you can you state your question one more time? I'll try to keep it in mind and I'll try to find its
Ma'am, my
answer.
question was random function. When we find random, we give a range 1 to 220. Now we stick to 100. Point is
Yes.
that when I mentions probability 0.2, we get 10 random numbers of 2-digit only. My
Yes.
point is that why we are not getting 1-digit number like 1 to 9.
That is the case, sir. If you are past here 10, in that case only it will give you 1-digit number like this. This is the
But
case.
if I pass 100,
the function is like made like this. If you want to get a 2-digit number, so you need to pass here the 3-digit number. And if you want to get the 3-digit number, you need to pass here the 4-digit number in place of the size. This is the
but
this
I
function
want
is,
any one random number between 1 to 100. So it can be 1 digit, it can be 2 digit, or it can be 3 digit.
sir, it
For
can be. I
that-
understood your point, but thing is, I am only talking about the R binom function. So the capacity of R binom function is that only. So you need to understand this thing. This function is made like this, which can give us the, and one more thing, as I said, this whatever number is generated here, you can see I have stored them in a X, and then I have plot them on a X I have plot them using the hist function. Hist is the histogram function. So meaning is that whatever 10 numbers we are generating, they are following the binomial distribution here. So the capacity of this function is that it will give you those 10 numbers who can follow the binomial distribution. Similarly, I'll show you afterwards also when I'm talking about the normal distribution. Similarly, we can generate the normal random numbers also, which can follow the normal distribution. So capacity of this function is that only, sir. So this function is made up like that. Okay, is it
I
clear?
was just making some trial, and in my case, as you see, first I tried with probability 0.8.
Yes.
100. My screen visible?
Okay, I haven't seen you have shared. You need to tell me because when I am on my screen, I cannot see what is going behind on the back screen. So you need to
Okay.
tell me that. Okay.
Okay, no issue, ma'am.
Yeah,
So it's visible now, ma'am.
it's visible. It's visible, Sanjay. sir.
So first we consider the range. We say 100, 10 number probability 0.8. So it generate all two digits number.
Hmm.
Next time I increase the range 1000 probability again 0.8. It generate all the three digit numbers.
Hmm.
Next time I change probability to 0.1. Keep three digits. Now there are two digits as well as three digits, but not we can say any
One digit number.
one digits. So
Sir,
if
you
for
need to understand this thing, Sanjay sir. This is a random number generation. So maybe you can run this 2, 3 more times, same line, line number 18.
now most of the two
Yes,
digits
yes.
and
These are the random numbers, sir. So any number will be picked by the function because in the range it can take any numbers.
right.
Similarly, if you can
So
when you will
that's
decrease, yes, you will
now
decrease
I
the
change the
yes.
probability.
This
Now
is what my
include
next point.
probability
Yes,
0.01.
yes. If you will decrease the probability, maybe you will get the smaller numbers also. Yes.
So I think there is some logic when I change the probability below one. Now I am getting one or two digits, but not getting three
Six
digit number.
digits number, right? And when
So
you are reducing the probability, you are reducing the probability from maybe you have bring it to the 0.01. So that
yes,
way you
ma'am.
can see the changes in the output. And when you will run this again, you will get the next output.
Definitely 10 different number, but I
Yes,
think now I will get most of the number
single
in the
digit
range of one
number,
digit and two digits.
2 digit. Yes.
Okay, great. Thank you, ma'am.
Yeah. Thank you, sir. So
Ma'am, I have one question.
Excuse me, ma'am.
yes, Sandeep sir.
When histogram I'm trying to plot on X,
Yes.
its error message is coming like figure margin.
Sir, you
Too
need to
large.
increase the size of your fourth window. Because there is a problem of access and it is not able to print that. So that is you need to do.
How to increase, ma'am?
Okay, so let me share my screen. I think yes, I can share now. Sir has just stopped sharing. Or my screen is visible to not or
No,
not?
no, not yet.
Not. I think
Yes, yes. Now about
it's. I think it is. Yeah. Now it's coming. So like this, you need to keep your cursor on these division, and once you will keep, you would be able to see a picking type of icon, and that will help you to increase or decrease the size of your window. You can see I am rotating it like this. Are you understanding? My screen is visible.
I increase, but still it is not coming.
Sir, you need to increase and then again you need to run the same line.
Oh, okay, 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 then. Okay.
Yeah.
Thank you.
Yeah.
Ma'am, I have one question.
Yes, sir.
That P binom which is there,
Yes.
yeah, on your screen, if you're sharing it,
Yes.
yeah, can you just put P binom
Okay. Yeah.
in bracket 600,
Hmm.
comma 1000,
Hmm.
comma 0.5,
Hmm.
and it is giving me the answer as 1.
Hmm.
So I could not understand, the probability maximum is 1. So this is
Yes.
giving me, even if I'm selecting this one, by default we say that it is uh, uh, less than or equal to 600
Hmm.
out of 1000. So still it is giving me, with probability 5, it is giving me 1.
Also, generally we can say there is a theorem called central limit. Maybe I am not sure that this logic may be perfectly fitted here or not. So generally, but that theorem which I am going to tell you here, it is generally applicable in case of normal distribution. So generally, when we are increasing the sample size, so maybe that is why the probability is tending towards to the 1. That can be a logic. So when you are increasing this size, when this particular trials are increased, so that way might be possible the probability of reaching towards to the 1. This is the problem of the R. It is not giving you the exact probability. When you will do it manually, in that case, maybe you will get some difference. Maybe it can be a 0.99, 0.9 point something. So that's why it is giving us 1.
Okay.
It is
Now, if we
0.999 something.
change it 600 to 400,
Hmm.
then it is giving me in very, very negligible small, like what you have got E minus 11, I am getting minus 10. Yeah.
It is a very
That is-
small probability.
Yeah, small probability.
Yes.
So, and we change it to 500, it just gives half of that, 0.5.
0.5. Yes.
Yeah.
Yes. Yes.
So, this is a little bit which is I wanted to understand.
Yes, so this is, as I said, so because maybe this is a capacity of, because these are what, so these are the functions which are developed by the programmers, right?
Okay.
So
Okay.
maybe this can be the reason, maybe the answer is coming like this, 0.999758 or something. So that is why it is coming at the round of as 1. Got
Okay.
it? In case of
Hmm.
600 or 700 or something.
Okay. Thank you.
Okay, thank you, sir. So can we proceed? I think it's a healthy discussion we have done. Very good. I think this brainstorming will even make me to think how to give the answer. So I'm expecting this. Thank you, everyone. So I think, may I proceed now further?
Yes, ma'am, please. But ma'am, increasing the margin, what you said is still not working. I increased too much, but
Okay, so
still
what
it's
is
not
giving you problem? What is the problem still you are facing, sir?
working. Same message is coming.
Okay.
Error in plot dot new
Hmm.
figure margins too large.
Okay, so sir, I'm stop sharing my screen. If you can share, can you share your screen?
Yes, ma'am.
Yeah,
I'm
so I'm
sharing.
stop sharing. So will you please share so that I can also see, maybe possible we can correct it or find it or short it.
Okay, ma'am.
Yeah.
This is my screen is visible
Yeah,
now.
very, very much clear, very clear,
Yeah.
visible.
So here I tried this. It's correct. Then again it's coming. Okay. Then when I do this, again same message is
So
coming.
do one thing, you can see the upper means upper, not this, upper one, the upper window, right side, upper window,
Yeah.
the division you can see. No, sir, it is
Yeah.
not.
Oh, okay. Fine.
Right, yeah.
Yes,
Here
yes.
you need to increase this. Maybe this can be also one thing. Now again, please run the line.
Yes, ma'am. Yeah. Oh, yes, it's coming now. Okay, thank you,
Yes.
ma'am. Thank you.
Yeah, thank you so much, sir.
Stop sharing.
So my screen is visible now. Anyone?
Yes, ma'am.
Yes, ma'am. Yes.
Yes. So now we are moving towards to the next distribution, that is the Poisson distribution. So the Poisson distribution represents the probability of a provided number of cases happening in a set period of space or time if these cases happen with the identified constant mean rate. So the in the simple term, if I want to make it clear that what is binomial Poisson distribution is, so it is very much like the binomial distribution. The only difference is in binomial distribution we are generally considering that there are only two outcomes, but in and again the probability can be greater than, or the can be the large enough in case of in comparison to the Poisson distribution. In case of Poisson distribution, the probability will be less, and whatever the events we are studying in the Poisson distribution, they would be the time bound events. Somewhere time constant would be there when we are talking about the Poisson distribution. Say for example, if I say in a telephone booth, in last 10 hour, in last 1 hour, how many people came for making a call? Similarly, in any particular clinic or dispensary, how many patients has visited that dispensary or clinic in last 10 minutes? like that. So that way, whenever we are talking about the time engagement or time, what I can say, association with particular event, that way it is known as the Poisson distribution. And generally, binomial distribution turns in the binomial in the Poisson distribution when the sample size increases and probability decreases. So sample size can be the large enough in the Poisson distribution, and the probability value will be decreasing here. So that way, this is the case of Poisson distribution. Now talking about what types of functions we can use in R to get the Poisson distribution. So you can find here, we are having the D poise, P poise, Q poise, and R poise. All are similar as the binomial distribution. That means D poise will give you the probability of the exact outcome. P poise will give you the probability of less than and the greater than case. Q poise will give you the probability of the getting a particular random variable, and R poise will again help us to generate those random numbers which are following the Poisson distribution. So these are the cases of, or these are the functions which we can use in the Poisson distribution. So is it fine? Can we move with the Poisson distribution now?
Yes, ma'am.
Yes. So here you can see, I think I have not written the question completely. You can read here. The question is, a manufacturer who produces medicine bottles finds that 0.1% of the bottles are defective. The bottles are packed in the boxes containing 500 bottles. Now next is containing 500 bottles. A drug manufacturer buys 100 boxes from the packed producer. Of bottles. Find how many boxes will contain, first thing, no defective. Second thing, at least 2 defectives. So this is the case. You can read the question one more time. A manufacturer who produces medicine bottles find that 0.1% of the bottles are defective. The bottles are packed in the boxes, contain 500 bottles. A drug manufacturer buys 100 boxes from a producer of bottles. Find how many boxes will contain, first, no defective, and second one, at least 2 defectives. So how we can solve this? I think formula I have already shown you. These are the formulas. How we can solve that? Lambda is the mean value. Lambda is what? Lambda is mean.
For first case, ma'am, will D poise, and
D
for
poise,
second
very
one,
good.
P poise case,
P
ma'am.
poise, very good. P poise and D poise we will use. Very good, sir. So how we can use that? D poise. What would be our X value here? Yes. What would be our X value here?
0.
0. Okay. Then mean value would be
500.
no,
1.
No.
Look is
I think I can tell you here when we are talking about mean for this, the formula is this: mean equals to n into p. N is 500, p is 0.1%.
50.
So 500 into 0.001. It's 0.5. Correct?
Ma'am,
It
but
is 0.1%. It's 0.1%. Please read it correctly. It's 0.1%. N is the sample size, P is the probability. So we will multiply these two and we'll get the mean value as 0.5. It is correct? Everyone has got it? Yes?
Yes, ma'am.
Yes. Good. So here, now I have passed here 0, comma. Next is 0.5. Then what next we need to pass?
सभी लड़कियों महिलाओं को घर बैठे आप जान सकते हैं कि आपका यूरिक एसिड तो नहीं बढ़ा हुआ। आज मैं आपको बताऊंगी ऐसा एक पॉइंट जिसको आप पाएंगे तो आपको समझ आ जाएगा कि मेरा यूरिक एसिड बढ़ा हुआ है।
Ajaz sir,
पहले कि आप ब्लड टेस्ट कराएं।
Ajaz sir, thank you. Ajaz sir, will
Yes.
you please, I think sound is coming at your end.
यूरिक एसिड आप ठीक करवाइए।
I think TV or something is running at the background. Yes. Can we proceed?
Yes, ma'am.
Yes. So I think you can see we have got the answer. It is 0, 0.5 because we need to pass through two things. First one is the value of x and second one is the value of mean. Lambda is what? It is the mean. We have calculated the mean on Excel and we have kept here the value. So that way we can got the value of deposit at 0.606 or it's 0.6 or it is 60.65%. It is clear to everyone?
So
Can
when
we
we
go?
have to use log equal to false,
No, you do not need to use here, sir.
so in which cases or it is by default not to use?
Just a minute. I think I can show you. We have taken the help. You can read it here. Logical if true, probabilities P are given as log P. So whenever the values are given in terms of log, so in that case you need to use that. If not, you do not need to use anything here. Okay, sir? Hello?
Yes, ma'am. Yeah,
Yes.
yes, ma'am.
Yeah. Now,
Ma'am, in this case, we will not consider the number of boxes.
number of boxes, sir? No. I think you need to see the formula. Formula is demanding only x and formula is demanding the lambda. So lambda is the mean value. X is how many defectives we are expecting. This is the x. So that way we have kept here 0. Lambda is the mean. We have kept here the 0.5. So that we will not consider here, sir. Boxes we have 500 boxes we have considered to get the mean value. Okay, sir?
No, ma'am, we have 500 bottles in one box and total box are 100. So for lambda calculation, we consider only
Bottles and the p value, because we will find the defectives in the bottle and not in the boxes, sir. We will find defectives in the bottles, right?
yes, and in one box we are saying there are 500 bottles. So in one box we calculate the mean value is 0.5.
Because mean is what it is on an average we will say na. So for one box we will calculate and we'll say on an average there would be 0.5
for all 100.
For all 100 there would be around 0.5 defectives.
Right. Thank you, ma'am.
Yeah. So now we will go for the p-poise. And now in p-poise we need to find at least 2 defectives. So what I need to write here? Yes, anyone? This is the formula for p-poise, same. Only lower dot tail will be used here. So what I need to pass here?
is 2.
Okay, 2. Then?
0.0.
Okay, then? Next? Anything else?
Lower tail equal to false.
Lower dot tail equals false. Is it okay? May I run this? Any other answers? Can we, is it whatever I have written, it's correct? Can I run this?
No, it will be lower dot tail should be true.
Yes. And by default, I think lower dot tail is true. So I think only this will also suffice to run.
So here we are not taking sample size or the 100 boxes anywhere.
I think question was what? It was at least or what? I think
No, no.
question was at least. No, I
No,
think here we need to find at least 2, right?
no, at the purchaser buys 100 boxes. So that was the
No,
question.
second condition was, sir, just a minute. Second condition was what? We need to find at least 2, right?
Yeah, 2 defectives.
At
How
least
many
2
boxes
defectives.
will contain?
Yes,
Yeah.
at least 2 defectives. So in case of that, we need to pass here false. At least. At least means minimum. Minimum 2. It can be greater than anything, or it can be anything. More than 2, it can be anything. Right?
Yeah. So then
you
here
need
it
to
will be 1, no?
1. Where, sir?
At P poise 1. Because if we are telling greater than,
Yes.
yeah.
Very good. Thank you, sir. So that way we will get the correct answer. Yes. And what was your question, sir? What was the question you were asking?
So we are not using anything that the 100 boxes. So that 100 we are
No,
not
that
using
is the
anywhere in
extra
this.
information. That is the extra information for us.
Okay.
Okay. So it is fine. Are we done with the depoys also? Done?
Yes, ma'am.
Yeah.
Yeah. So we will move for the normal distribution now, and then we will see some exercises so that we can get some more understanding about these functions. Normal distribution is very important to understand from the point of view of the research and academics, because when I'm talking about normal distribution, for the maybe I think most of you are very learned, so you have heard about the parametric test, you have applied also. So for parametric test, this is one of the major assumption or major condition, important condition, that your data should be normally distributed. So what is the meaning of normal distribution? That I'll tell you, that when I'm talking about normal distribution, the data should follow the bell-shaped curve. And bell-shaped curve, maybe you have seen it. Anyone who have seen the bell-shaped curve? I think in
Yes,
Google.
Yes, ma'am. Yes, yes.
Yeah.
Yes.
So maybe I think that would be like this bell type curve it should be. So the meaning is that whenever I have a data and I'm plotting that data, suppose on histogram, and on histogram also we can keep that bell-shaped curve. So if most of the bars are coming under that bell-shaped curve, I can say that data is approximately normally distributed. This is the one case to understand the normality of the data. Apart from that, there are certain characteristics through which we can understand that data is normally distributed or not. Say, for example, if I have a data, I have calculated its mean value, I have calculated its mode value and median value also. So all the 3 central tendencies I have calculated for my data. And if suppose these 3 values are either equal or they are very nearby, in that case, I can say this thing, that data is normally distributed. Apart from that, there are some more things which we need to have to understanding the normality of the data. Maybe you have heard about skewness and kurtosis. So skewness is what? Skewness is the study of asymmetry in the data, means whether the data is asymmetric or symmetric, or whether the data is skewed or not. So you need to see this thing using the skewness. If skewness value coming as 0, so that way I can say that data is, or in data there is a symmetry. Symmetry meaning is that the mean will fall at the middle, and 50% data will go, or 50% data is less than to the mean value, and 50% data is the above to the mean value. So that way I can say skewness will help us to understand the curve of shape of my curve. Similarly, second parameter is the kurtosis. Kurtosis is what? It will tell the story about the peakness, or maybe as you said, you have seen the curve. So peakness we can study with the help of kurtosis, or that heaviness or the lightness of the tails we can study with the help of those this kurtosis value. So if kurtosis is again coming as 0, so again we can say that data is approximately normally, data is exactly normally distributed, or it's perfectly normally distributed. But in real life, it's very hard to get a normally distributed data, or our data which is having a 0 skewness, or which is having a 0 kurtosis. So in that case, we can say, in such kind of cases, we can say this thing that if suppose the skewness value is coming in a range, for example, plus minus 2, or the kurtosis value is coming in the range of plus minus 2. So we can conclude this thing that the data is approximately normally distributed. It would not be the perfectly or exactly normally distributed, but we can say somehow it is approximately normally distributed. And that way we can proceed with the parametric test. So today I am only tell you the 4 functions which we can use to get the probability of the normal distribution. In upcoming sessions, when we are going to discuss the parametric test, in that I'll tell you how, with the help of simple function, we can get the value, or we can understand whether the variable is normally distributed or not. So today I am confining the discussion or the session with the only 4 functions which we have already seen in case of binomial and Poisson distribution. In case of normal distribution also, we will have the same 4 functions, that is d norm, p norm, q norm, and r norm. So these 4 functions, again, d will give you the exact probability of the outcome, p will give you the less than and more than case, q norm will give you the probability when we will pass here the function, or when we will pass here the probability, it will give us the variable. R norm will help us to generate the random numbers which are which are following the normal distribution. So now you can see I have taken a question here. Is it visible to everyone? The word file?
Yes, ma'am.
Yeah. So I expect you to please read it so that we can perform this thing on the R. The question is, assume that the test scores from a college admission tests are normally distributed with a mean of 450 and a standard deviation of 100. What percentage of people taking the test score are between 400 and 500? Suppose someone received a score of 630. What percentage of people taking the test score better, and what percentage score worse? Last, if a particular university will not admit anyone scoring below 480, what percentage of the persons taking the test would be acceptable to the university? So this is the question given to us. Now we need to apply the formula or the functions which I have already shown you. So the first case is the case of the in between. You can see here 400 and 500. So here which particular function we will apply? Say for example, I have written here I think p binum. No, it is not there. Yeah. So firstly, I'm writing here, suppose question mark sign. Then I'm writing p norm function, pressing control enter. You can see it is giving me all the parameters of all the 4 functions. So these things you need to pass. If we need to use d norm, we need to pass x here, mean value, standard deviation value, and the log. It is a optional. If we will not pass mean value and standard deviation value, you can see it is written 0 and 1. So by default, if we will in d norm function, if I will only give the value of my random variable and I have not passed the value of mean and a standard deviation, so by default mean will be considered by 0 and standard will be considered as 1 by the R. Similarly, p norm, q mean, standard deviation, and lower dot tail we can pass here. In q norm we can pass here p mean, standard deviation, and lower dot tail. Similarly, in r norm we can pass here n mean and standard deviation. So this is the case. So now, as I have shown you all the 4 functions, and question is also, I have shown you once more, we are going there, you can see. So mean is given as 450, standard deviation is given as 100. Now the value of x is 400, firstly, and second it is the 500. So now how we can solve it? Can anyone tell me? Or I need to tell first thing, as you say.
Probability of 500 minus probability of 400.
Very good. Who has given this answer?
It's me, Sandeep, ma'am.
Thank you so much, sir. So P norm. Now Q is 500, comma 450 is mean, and standard deviation was 100. Now, suppose I have kept here false. Okay, that way it will give me the probability of what? Is it correct? I have written it correctly. Any doubt? Yes. It is correct. May I move further?
Yes, ma'am.
So the concept is clear. What we will do here? Is it okay? Anyone, will you please confirm me? Is it okay?
Yes, ma'am.
Yes. Now the second case was, suppose someone received a score of 630. What percentage of people taking the test score better, and what percentage score worse? In this case, what we will do? We'll go with P binom or D binom. Sorry, P norm or B norm.
P norm.
Very good. 630, comma 450, comma 100. And then, do I need to pass something else, or it is okay? This would be the case of better or worse.
Better.
Better. No, it's worse.
Worse.
Yes, because it is a less, true is what? Less than or equal to. So when the score will be worse, when the people are receiving marks less than or equal to 630. But people will get marks more than 630. That would be a better condition, right? Right?
Yes, ma'am.
So here you need to pass, for the better condition, you need to pass false. Chances are very around 3.6% chances that people will score more than 630 marks. Right?
Ma'am, the question asked both of the scenarios, the percentage who scores less and the percentage of the people that scores more.
Hmm.
So we have to perform this twice.
Twice, yes. For worst condition and for the better condition, both. Okay, sir?
Yes, ma'am.
Yeah. Lastly, if a particular university will not admit anyone scoring below 480, what percentage of persons taking the test would be acceptable to the university? What would be the answer? Again, which function I need to apply here? P norm or B norm? Sorry, P norm or D norm? Anyone?
P norm.
P norm. Very good. Then 480, 450 and 100. Do I need to pass something else here? I hope everyone has read the question. Question is, if a particular university will not admit anyone scoring below 480, what percentage of persons taking the test would be acceptable to the university? So what I need to pass here? True, false or nothing?
True. I guess true.
True. Okay. Anyone else? True. Can I write true?
Ma'am, it would be false because the
Yes.
university wants more than that.
More than that. Very good.
And that also not 480. We can keep it 479.
479. Very good, sir. So that way it will give you the answer. So around 38% people will be admitted. Done? It is clear to everyone now? Yes?
Yes, ma'am.
Yes. I have taken few questions for all of us, so I can show you one by one. So the first question is this. Yes. You can read the line number 212 and 13. How many heads will have probability of 0.25 will come out when a coin is tossed 51 times? What I need to do here? Which functions we will use here? Yes.
D binom, ma'am.
D binom. Okay. It is okay, done. Everyone is okay with D binom, that we will go with the D binom. Yes. Any
It should be-
changes or yes?
It should be Q binom
Yeah, very
P,
good.
because the probability
P,
is
yes.
given.
It's
P.
noted. Yes, P
It should be
binom.
P. No, incorrect. I think someone has said Q. Is it? Or I have heard because it is in my mind.
No, Q binom because probability is given.
Yes, very good. Because probability is given, they are asking me how many heads will have a probability of 0.25. So here you need to pass 0.25, comma 51 trials and probability of head is 0.5. Right? 23 out of 51 heads, the chances of coming or the probability out of 51 heads, the 23 out of 51 trials or toss, 23 toss will turn up to the heads. This is the probability. Probability is 1 by 4 or 0.5, 0.25. Is it clear to everyone? So you have understood how you can use Q binom? Everyone? Sorry, any doubt? Can we go for the next question? Question is, find 8 random values from a sample of 150 with the probability of 0.4. What I need to use here? I think any
Ma'am, I
function.
had a doubt in the
binom.
previous question.
Yes.
So the answer that we got is 23. So 23 heads will have the probability of 0.25 when it is tossed 51 times, right?
Yes.
Okay, ma'am.
Sir, you can do one more thing. See,
Yes, ma'am.
we have the opposite case also. You can write here 23, 51, 0.5. Just a minute. Approximate 0.25. This is the case. Opposite means when we are using P binom, it will give us probability. When we are using Q binom, it is giving us the X value. So when I'm reusing this, you can see I am getting this probability values. So it is almost it will not give you the exact answer, but it will give you approximate answer. So this is the answer. You need to use p binum.
Okay, ma'am. So this is a good method to cross check.
Cross check, yes.
Okay.
Next, find 8 random number or find 8 random values from a sample of 150 with a probability of 0.4. What I need to do?
R binom.
R binum.
R binum. Very good. R binum using 8 out of 150, comma 0.4. Now next, probability of getting 26 or less heads from a 51 tosses of a coin. What I need to do?
P binum.
Very good. I think Vaishnavi ma'am is saying very good. It's P binum. I need to now what parameters I can pass, Vaishnavi ma'am? Here, what I can write next. First parameter would be what?
26 or less heads from
Hmm.
51 tosses. 26.
Then
51.
hmm.
And probably we need to find, right?
And
So
what it would be?
51.
No.
Oh, 0.2.
No, 0.5. It's
0.5.
head, ma'am. Head, na? When we are tossing a coin, so outcomes are only head or tail, and probability of coming a head is 0.5 and coming a tail is also 0.5. So this is the probability of success we need to pass here. Apart from that, do we need to write here true or false something, anything? Or it will suffice?
Or less. So I guess true. I don't know. I'm confused in that true or false.
Ma'am, it's true. By default, it's true. So I do not need to write, and you have said correctly. This would be the answer.
Okay.
Yes. True is what? I think do not keep any confusions in mind. True meaning is what? True will give you the probability of less than or equal to k. So here it is asking you less than or 26 or less. So 26 or less equal to this is the case. So that is why we are going with the true. And by default, this function takes it as true only. If it is asking you more than 26 heads, in that case, you need to pass false after 0.5. Okay, fine, ma'am.
Yes, ma'am.
Yeah. So everyone is through whatever I just discussed.
Ma'am, can you give a question designed for when we have to use log P?
I need to do exercise for that, sir. So I'll search and I'll give it to
Okay.
you. Is it fine?
Sure, ma'am.
Yeah. So this is all from my side for the day. Any queries or anything you want to ask me? The platform is open. Can I stop share my screen now? Any doubt? Anything you want to ask me?
Ma'am,
Yes, sir.
excuse me, ma'am.
Yes,
Actually,
Sandeep, sir.
yeah, yesterday's exercise,
Yes.
I tried to plot two comparing bar graph. Na?
Okay.
Suppose a student, 5 students has got different marks in science and maths. How to plot in the histogram bar graph? No, bar graph maybe. So that formula I tried, but I could not able to get. A single bar graph is possible with color and all whatever you have shown, but when comparing two subjects or two individuals, I hope I'm clear. My question is clear, ma'am.
Means you want to ask me about the stacked bar graph or something?
Yeah, yesterday's class.
No.
Based on
My question is, you are asking about the stacked bar graph or something?
Bar graph, simple bar graph, comparing two data variable to maybe science and math score, that I could not able to do.
Can you share your screen, sir, so that I can help you out?
Okay, ma'am.
Yes.
Okay, My screen is visible, ma'am?
It's visible. It's visible. Sir.
Ah,
You can,
okay.
yeah, you can make it here, or you,
Yes,
if you
yes.
have, you can show me.
Actually, I tried. It's already there. Mm, whole day I was trying, but I could not able to make anything. For example, this one, this score. Um, yeah, here this is there. Okay. Yeah. Suppose, yeah, this one. Suppose maths and science score.
Hmm.
Uh, yeah, I tried like this also. It was not working. I did plus also, but it was not working. This was I just tried. Uh, yeah, this maths and science score, for example, and this must show two different graph comparing maths and science score between the three candidates, first, second, and third.
Hmm.
That is not cannot be plotted, ma'am. That I tried, but single I can do, but multiple one.
I can. It will. I think it will work, sir. You can you write there bar plot? Next
But
line. In the next line, I think in the new line you can write the syntax.
here, ma'am.
Wherever you want, but you need to write it a fresh line. Enter. You can press there.
Okay, okay, okay.
Hmm. Bar
Please
plot.
tell me. Bar plot.
Then you can write the name of your variables.
Data equal to
Hmm.
df2. Am I right?
Hmm. I think that rather than doing this, you can directly write from
Okay.
in which I think it is from you are taking from the data frame, right?
Yes, yes, ma'am.
And the name of data frame is df2.
Yes.
Now after that you can press dollar.
Okay, okay. Dollar data
After
plot.
df2, after df2,
Okay, okay. Dollar. Okay, okay.
then math. I think it is showing there, sir. It is showing you. You
Yes,
can
yes, yes,
select.
yes,
You can go with the
yes,
suggestion.
yes,
Yes,
yes.
comma
Comma
df2 dollar.
df2. Okay, okay, okay.
Next variable name
Science. Yeah,
and press Control Enter now. Do it.
yeah.
Are we getting it or not?
Okay, okay. Yes, yes.
But it
I
is not
think
showing it much correctly. You can do
yes.
one thing. Use after the df2 dollars sc. Please put comma. No, not here.
Ma'am, just
In
I'm
the
trying
okay.
this
In
one.
the
Maybe
bar
because of
plot
this.
after sc. After
After
sc.
after SC. Yes.
Comma comma
Comma col
equals
equal
c small c
small c.
in brackets.
Yes.
Give the name of any two colors.
Okay, okay. Inverted comma. I mean,
Yeah.
blue.
Comma. After double quote comma, yes. Now press Control Enter.
Okay. Still something is not. Still something is.
Missing.
Yeah, yeah, yeah.
Like
Ma'am, like math score, there are maths, three students are there, science, three students are there. 23 and
so
32 should be together, and comparing both two bars should be together. And 34, 35 should be together. And 45, 46 should be together again in pair. Normally in MS Excel, what we do.
yeah, in Excel it is quite clear. I think I understood your point, sir. You want to compare the scores of students maths and science, means what
Yes,
a
yes,
student has scored in maths and what a student has scored in Science. You want to compare the marks. Okay, so
Yeah.
I'll let you. I'll show you this thing tomorrow. Okay.
Okay,
I'll show
ma'am.
you
Okay.
this thing tomorrow. We can do it in this. We can do it. So I think as the time has, I have to leave. So tomorrow I'll
Hmm.
show you this.
Okay, ma'am. Okay. Okay. Thank you.
Yeah.
Thank you, ma'am.
Okay. Thank you so much, sir.
Good night.
Good night. So thank you, everyone. If any queries, so I am here for a minute also. So if you have any queries, you can ask me. Yes. Any queries so far?
Ma'am, what we discussed about the probability of the between 400 to 500, that problem. So when we do it manually, okay, the value which is coming is different, and here what the value is coming, that is different.
Sir, for which question you are saying me?
Uh, this was for that mean is 450 Poisson distribution, standard deviation is 100, and how many people got between 400 to 500.
Okay, what answer we are getting, sir? I think I forgot the probability value. What was we were getting?
0.3829249.
And there what they are getting? And when manually what you are getting?
Manually, if we do it and see from the table, so it is 0.6170.
Maybe, sir, I think as I said, we need to use the logic. As I said, we have used the 400 and 500, right?
Correct, correct.
So that means less than 400, right?
450, yeah, no,
Because we have not passed there the true or false. So by default, it is true. So true
Okay.
means it will give you the probability of less than 400. Similarly, 500 also we have taken. And
Yeah.
then from 500, it will again give you the less than. So when I
Yeah.
am subtracting from 500 to 400, it will give you the middle frequency of in between 400 and 500. I think logic we have placed it was correct.
Yeah, logic is correct. And
Hmm.
even if you plot the graph, so in the mean will come in the center 450.
Yes.
Okay, and we are taking 500 and we are taking 400. So it will be symmetrical. Both should be same.
Both should be, yes, correct.
Yeah.
Difference
So
is 50 only. From 450, it is 50 less, and from 450, it is 50 more.
yeah.
Yes.
So maybe I will check it again. And
Okay,
because you are getting,
I'll also work on this. I'll also check the answer. I think I have taken this question from a book or somewhere. So I'll check
Yeah,
the
yeah.
answer there also. Okay, sir?
Okay, okay, ma'am.
Okay.
Thank you.
So thank you, everyone. We will meet tomorrow. Good night, everyone.
Thank you so much,
Ajay,
Chanchala
sir.
ma'am.
Yeah.
Thank you so much.
Yes,
Thank
Ajay,
you,
sir.
ma'am.
I was about to call you that I'm leaving now.
Yeah, yeah.
Yeah. Thank
Thank
you,
you
sir.
all participants, and thank you again, Chanchala ma'am. Thanks a
Thank
lot.
you, sir. Thank you, everyone. Thank you, sir.